Welcome back to the lesson room for CSGO.
Yay.
We're continuing with functions.
More functions. Got 3 weeks in a row of functions. They're a pretty cool topic. Lots of stuff you can do with them. But they do have a few... I'm not sure I can quite call them unintuitive, but there are certainly some strange properties. So, I believe last week I was only half paying attention, showing an example of what you shouldn't be doing right now. You talked about the basics of functions. You make a function definition, and then you can run the function. In this case, it's technically a procedure, but we're going to use the terms interchangeably. So the main topic of today's discussion is something called scope. So scope is handled a little bit differently in Python than it is in a lot of other languages, but it's still relatively similar, and it's the same sort of concept. So the basic idea is that functions you create inside of a function, variables you create inside of a function can't be used outside of the function. So this means if you have something like a temporary variable you store a value in inside the function, you can't then reference that variable outside the function even if you've called it. So in this case, Trevor is setting y, a variable y, to 1. Okay, sure. And then you want to print f of x, or print f of 2. Alright, so if we try to run this, it'll fail, because y is not defined. So the basic idea here is we're defining y inside the function, and it stays encapsulated inside of that function's scope. So whenever it doesn't exist here. So a really good way to check whether or not a variable exists is to just try printing it, because Python can print just about everything, and if it doesn't print, it doesn't exist. So when you do try to reference one of these variables, Python always starts in what's called the local scope. So in the case of inside that function, that would be the local scope inside the function. And then it'll check in the scope. Oh wait, actually I have an example here. I'm gonna send it to you real quick if you wouldn't mind opening it.
Is it this one? Scope example?
Yeah, there you go. So each of the functions has a local scope, and whenever you try to reference a variable, it'll check the local scope, and then it'll check the scope above that, and so on, all the way up until what we call the global scope. And these are all just fancy names for the different tiers of scopes. So I guess you can try uncommenting some of the lines and running it a few times, seeing what happens. So you want to explain what it's doing?
Oh wait, I think I have to fork this because it's not shared with me.
Oops. That's fine.
Okay. There we go. Expected behavior. So, let's see, let's just run through the program. So here we set x to global scope, and then we go into the function. There's a function call for my function down here, and a print x. So in my function, x is set to my function's local scope. And then we define another function called inner function, which it looks weird, but it works. So in this inner function, we set x equal to inner function's local scope. And then we print x. And like Kegan says, it first checks for x in the local scope, then it checks for the scope above that and then the scope above that. In this case, this x already exists in this local scope. So like in this scope right here. So then when you print x, it prints inner function's local scope. But then when you exit this function at the end of this function call, so once you get to line 17, there's another print x, or another reference to x. And then now it checks this function scope. And in this function, this little nested scope here is out of scope. So this x doesn't exist. So then this x is the first x we see. So then it prints my function's local scope. And then we exit out of this function at the end of this function call to line 21. And then since all of these x equals are in a function here, and we're not in that function here, like we're outside of the function, then the only x that exists is x equals global scope. So we print global scope. Then if you comment out this one, I guess, print my function's local scope twice, because it first, in this print line, in this scope, it first checks for an x equals, but there's no x equals, so it checks for the scope above, it checks this scope, and it finds x equals my function. Right.
So one more thing to keep in mind is this works for functions as well as variables. So inner function is confined to my function scope, and thus could not be used outside of the the surrounding function. I don't believe that'll work. So this might seem a little bit strange, like arbitrary restrictions. Why can't they just all be global? But turns out in a lot of cases that does a lot more harm than good. So for example, think about if you import, I don't know, have we talked about importing in the lesson room? I don't know, probably, maybe. So say you import, I don't know, some math library. I haven't done, is it import math? I forget. Anyway, you're importing math. Okay, so if this scope restriction didn't exist, then every single one of the variables defined in that math library would now be fully defined in your function, including the ones inside of the procedures and such, which would be a total headache, very hard to figure out, and it just keeps everything nice and clean. So, okay, what if you wanted that to happen? What if in that define f, you wanted y to be able to be referenced outside of the function? Well, fortunately, Python doesn't just, lock you out of that. It still gives you the option. And we can do that using a keyword called global. So can you define it as global and give it a value in the same line? I didn't know you could do that. Okay. Anyway, so you write global before you define the function, and then Python knows that you don't want to restrict the variable to just the inside of that function, and in this case, it will work.
Wait, does y have to be defined before the function? Like y equals 0?
I thought I just tested this. Right, let me open up my testing real quick.
Okay, well, let's try.
Global var equals 0.
I guess you probably have to call g first. So
Yeah. Oh, yeah. You do have to call g. Yeah, because the function isn't run.
Yep. Okay.
Nice.
Let's get rid of all this crap. Okay. So we're okay. Y equals 2.
So scope also. I forgot to test this before the lesson. Just give me just a second. Okay, so another interesting part of Python, and one of the things that it does a little bit differently, is how it handles scope in reference to loops. So we all know about loops, hopefully, and Python does not actually restrict the scope inside of a loop. A lot of other languages like C++ do. So Trevor's just making an example here where we define a function inside of the loop. And there are lots of reasons you could want to do this. It's not always helpful though, because the variable would be defined in each iteration of the loop, which is not. Oh, I guess you could use that as well. Just I, yeah, print I. So what's happening here is I is being created inside of the loop, but still usable after the loop has closed, which is a little bit, it kind of threw me off when I found that out, because not many languages are like that. Yeah. A little bit strange. Okay. This took a lot less time than I figured it would. Right, let me. If statements too, yes. That's probably a bit more of a practical example. A nice application of this is, I imagine many of you here are going to be taking or have taken Mr. Chapman's grade 11 CS course. And one of the things you do a lot in there is tkinter. And one of the things that you don't necessarily have to do with tkinter, but it's often it's almost always a good idea, is to have a main loop and to call functions from within the main loop. And if you have, like, I don't know, a setup function, then you're going to need to make use of these global definitions when you're setting your variables inside of the setup function. Otherwise, they'll all disappear as soon as the function is over. I personally really like having a really small main loop where everything's encapsulated into other functions, and I can just see it that way.
Does that work with the commas?
Yeah.
Awesome. Maybe they should be different names. Was there anything else that we wanted to talk about?
All I had left to do was just to, like, not an actual fully coded tkinter example, but a bit of a showing how it would work with tkinter.
Do you want me to switch to tkinter?
You don't have to, like, actually use tkinter. It's more to show how scope can be used. But if you want to, you can.
I'd have to reset up the recording, so.
Okay, yeah, then maybe not.
So, like, if these were parameters for your tkinter program, then you'd have a setup function, and you'd say global for all of these variables. Then after calling setup and setting everything up, let's set blah to this, then we see that all of these exist outside of this function's scope.
Mm-hmm.
Awesome. Do you want to go through some random stuff? Let's see what's the most obscure things we can find about functions. Are we planning on talking about recursion next week?
I think so, yeah.
Okay.
Yeah. We could probably just jump ahead a little bit. We got some extra time. I mean, I'm sure I can find more to talk about next week.
Actually, I just want to do one example, which is
Okay.
passing lists as parameters. Oh, everyone knows like the jargon, right? Where like if you had f of xyz, then the xyz are parameters, and the things you pass them are arguments. So let's say let's say a function called f of x, and it takes a list as an input. So let's make argument is equal to 2, 3, 4. Then we set x0 is equal to that number. Then we call f of argument and print argument. I guess this doesn't really have much to do with scope, but what's happening here is that we edited x, this variable x, and it changed the variable argument. And has everyone heard of what are they called? How lists are stored as references? I'll check that. Okay, awesome. So basically what happens is this list, it's not that it passes like, let's say if we had a function that was like a math function, where it's like g of x, then it would return x plus 2. Then you call g of 4, g of 5. Then it would set x in this scope. There would be a variable created called x. Well, that's really okay, how about I restart this? I'm sorry, guys. So basically how parameters work in a function is, let's say a function g of x, then it returns x plus 2. So what happens here is that this parameter is actually a variable in local scope. So when you do something like g of 2, then inside this scope, there's a variable created called x, and its value is set to 2. And that's why we can use x inside of this scope. And then that whole thing with lists was, let's say we had arg again, 1, 2, 3, 4. Then we have the function f of x, return, or not return, x0 is equal to random number. What happened here is that two different things happen. When you pass by a list, it does something called pass by reference. And when you pass a number, it does something called pass by value. And those are really weird. So when you pass by value, it constructs a new variable x, and sets that variable's value to 2. And then what happens is, let's say if you had y equals 4, then g of y, then it would create a new variable x, set it equal to the value of y, and then those would be two distinct variables. But if you have a list, lists are stored as references. So when you pass arg to f of arg, it does create a new variable x inside the scope, which is like, imagine it's saying x is equal to arg. But since lists are stored as references, it means that both variables are referencing the same thing. So when you change something to x, it also changes arg. And that's one thing that people really have to be careful about with lists. And I'm pretty sure you probably already know this from the list lesson. So like copying lists, x equals 1, 2, 3, y equals 1, 2, 3, or actually, y is equal to x. Then if you change y and print x, changing y changed x. That's because they're just the same thing. And that's
So
another weird part. Yeah, it's kind of
yeah,
a little
it's a little bit difficult because Python assumes this. Other languages don't. Other languages do. Can I delete this?
Yeah, sure.
So another thing we can talk about on the topic of arguments are these fun little things called keyword arguments. Trevor, do they exist in C++? I don't know. I haven't used them. I do know that they exist in Python. So say I have a function, find my function, and I want to take in some value at some value, okay, and some other number, okay. And what I'm going to do is, I guess I'll just repeat it. It doesn't matter what I do. I'll just repeat it, addition them real quick. So this is a fairly simple function. It's effectively just multiplication, but say I were to print 2, 3. Okay, easy and straightforward. However, let's say if I had a whole bunch of these, a whole bunch of or whatever, and I don't want to remember the order, I can reference them by their name. So I can say value is equal to 2 and x is equal to 3. And these are called keyword arguments of my function. And you don't have to do anything different in the function itself. The only difference is how you're calling the function. So let me... Actually, this is not a great example. I'll do it like this. No. Whatever. Okay. So as you can see, it still works. So I'm saying that the value here should be set to 2. The interesting thing that is not really represented very well with this example function that I've made wait, I don't need the space there. So I'll just run this one more time. So value is 2, x is 3. However, this gives me the flexibility of not caring about what order they're in. So now this is exactly the same thing, even though they're in the wrong order. And this is helpful in all sorts of functions. So here's print. Print is a perfect example. So, well, maybe not a totally perfect example because the way it handles inputs is a little bit difficult. But say I wanted to put an exclamation mark at the end here without doing something like, something like that. I could do comma end equals exclamation mark. And what this does is normally the end defaults to a new line character. And that's why whenever you print, it just automatically goes to the next line down below it. If you don't want that to happen, you can change what the end is. So I can put like a few characters in here. I'm going to put a few characters in here. And now it's no longer new line character. Now it's 3 dashes. So this is a keyword argument, and it's a very fun one.
Ooh, okay. So last thing I'd like to talk about, and I think it's the last thing, probably, right? Kegan, do you have anything else you want to talk about?
No, I don't have anything else after this. This is the last thing.
Okay. So, one thing, has
Probably
everyone heard of
open
dictionaries before? Dictionaries.
Yay, dictionaries.
Like the curly braces? If not, we'll skip half of what I'm going to talk about. Has anyone not heard of dictionaries?
I sort of know what they are. You use like and accesses something, right?
Actually, let's just do a quick definition right now. Yeah, it's like it's like a list, except instead of using indices, you use keys, and keys are just like strings or numbers. So it can be any string. Then if you print x my key, then it prints the value of my key. Okay, so that's a dictionary. I think we'll focus on the part that doesn't involve dictionaries first. So first, let's pretend we're the writers of Python and we're writing the print function. It probably looks something like this, right? Where it's like print x and then blah blah blah, put x onto the screen. But has anyone seen the print function used like this before? So like, hi, I am Trevor, where you put everything as multiple different arguments. And when you run it, whoops. Oh, that's because there's nothing in here. Let's see. Return nothing. It's because we redefine print. Let's call it my print. So the actual print function, when we type 4 different arguments, it prints, hi, I am Trevor. But then we can even add another argument, like an exclamation mark. And everything is separated by a space. So how do you write that, right? Like in my print, we only have one parameter, or 2 parameters, or 3. But we can't have a variable number of parameters, like this and this. Like in the
And it would then restrict. Wouldn't it then also restrict you to including all the parameters?
like in the print function that Python provides us, we can put as many arguments as we want, and Python will print all of them. And how do we type that in code? Well, we use the star operator. This is pretty weird. So let's make a new myprint. Myprint. And then this is weird. You put a star before the x. And then I forget what they're called. I think they're called list arguments or something. But what the effect is now is that, let's see. I'm going to type some weird code. I'm going to explain it later. For I in x, or usually they go like args. For x in args, print x. Now let's see this.
Quick announcement that attendance is open, so don't forget to log that. If you're listening to me right now, it should work for you. If it doesn't, let me know in general.
So the effect of this is we can pass as many arguments as we want to the function, like hi and go. And what happens here is that args becomes a list of everything that you pass through. So if we just print args, for example, or well, technically it's a tuple because of these parentheses. But yeah, it's just a list, and now we can put as many arguments as we want. Go. Sign. Attendance. And that's how the print function in Python does it. And what this is called is, in Python, they call it function overloading. In other languages, it's slightly different, but this is how you have more general behavior for your functions. Just like in print, where we can print, or maybe even the max function. Just like in the max function, where we can go like, have any amount of numbers. I think this works. And it still gives us the highest number from all of these. Instead of having to pass a list of numbers like this, we can just put them all as arguments. And sometimes that's easier, sometimes it's harder. This is just a tool that the guy who wrote Python decided would be pretty useful for us. All right. I guess if we still have time, I guess that's actually all I'll talk about for these types of arguments. I forget what they're called, but yeah, they're pretty useful.
Hey, Trevor.
Hey,
The comment in the lesson room chat about them being all on different lines.
all in the same line. Okay, my print.
My bad. Sorry.
We're just gonna.
So this should print them all in the. Okay, well, technically this will print out the list. If you wanted it to be printed out individually, assuming that you couldn't print them multiple at a time, then you would have to do them like that. But then that would put it on multiple lines. So then you could do n space. So it's probably a slightly better way to do it.
It's just the way that it's the way that we wrote the function, because we use Python's print, and Python's print always ends with a new line.
Mm-hmm.
So now if we just change the end to this, then yep. So from this we can see that the guys who wrote Python actually put a lot of like attention to make it so that we can do what we want to do. Hi, go assign attendance. And I think that's probably all we have to talk about for today until next week when we'll continue with functions. Functions 3. And I think Kegan said we're talking about recursion, which is kind of difficult to wrap your head around, but we'll get through it. So, wait, what is the plan for next week, Kegan? Where's he gone? Yep, make sure to do attendance. All right, stream over.